Hello, my name is Garrick Byrne. In the context of this video, I'll be playing the role of a consultant hired by a travel agency. In this presentation, I'll explain what work has been done previously on the topic. I'll show the objectives that the customer is requesting. We'll look at the source data that was available. I'll take you through my machine learning models and explain how I chose the most suitable model. And finally, we'll look at what customer traits are important for making a prediction, and by contrast, what customer traits are not so important. Let's get started. My client is a travel agency. The travel agency previously ran a sales and marketing campaign to sell a particular travel product. During that campaign, the company recorded a great deal of data about each customer interaction. We'll look at that data shortly. In this project, we'll use this previously gathered data to prepare for a new marketing campaign. The company is planning to start a new sales campaign in support of a new travel product. The company hired me to develop a machine learning model that it can use in conjunction with customer data to predict which customers are likely to be interested in the new product and which customers are probably not interested. In this process, we'll determine which customer characteristics are helpful for predicting whether they'll buy, and at the same time, which characteristics are of little predictive value. The data gathered during the last campaign can be grouped into 4 areas. As I go through these topics, you're welcome to pause the video if you want to study the field names. Data gathered includes the prospect's economic profile, his or her demographic profile, information about the customer's travel preferences, and what sales techniques were used during the meeting with the prospect. Also recorded was the very important information whether the customer purchased a travel product during the last campaign. It is this variable that the company would like to attempt to predict using my machine learning model. The customer requested that I create a machine learning model. I tried 19 different machine learning models using different machine learning algorithms and tuning techniques. Let me explain how I chose the most suitable model. There are several metrics available to measure the performance of machine learning models. The ones I used are recall and the F1 score. For reasons I'll explain shortly, I desired to minimize false negatives. Thus, I want to penalize myself for the false negatives. Looking at the formula for recall, note that false negatives appears in the denominator of the recall formula, which causes the false negatives to make the recall fraction numerically smaller. My secondary metric is the F1 score. The F1 score includes a penalty for false positives, which is something we kind of like to avoid as well. Now let's look at the model scores. I created 19 different machine learning models. Here is a list of the top 5 sorted by recall score. Recall that we're using the recall score and the F1 score to evaluate the models. The stacking classifier has the top rank on recall and it has the top score on F1 as well. I declare the stacking classifier to be the winner. This is the model I'll deliver to the client. Now that I've chosen the top machine learning model, let's see how the model performed with data it hasn't seen before. Before I created the machine learning models, I set aside a portion of the data as test data. This data was not accessible during the training of the machine learning models, but it is being used now to test the performance of our chosen model, the stacking classifier model. This diagram is called a confusion matrix. The confusion matrix helps us understand where our model is performing well and where it may not be performing well. Let's discuss each quadrant. In the upper left, we have true negatives. These are people that were not interested in buying, and the model correctly predicted they would not be interested. This is fine. We won't waste marketing resources reaching out to these people. In the lower right corner, we have true positives. These were prospects that the model correctly predicted would be interested in buying. Great! We'll focus our sales efforts on this group of customers. But now let's look at the mistakes. Look at the upper right quadrant. These are false positives, people that were not interested in buying a travel package, but the model thought they would be interested. Any marketing directed toward these people is probably wasted. Consider the lower left quadrant. These are false negatives. That is, the model guessed these folks weren't interested, but it turns out they actually were interested in buying from us. In my view, this is the worst of the two error quadrants. With the false positives, we lose the relatively small marginal costs involved in reaching out to those folks. But with false negatives, we miss out on sales revenue. This is why I chose recall as the primary metric, because recall would direct me to the model with the fewest false negatives. Now that we have a model we like, we can see which inputs, which characteristics, which traits the model considers to be important in making a prediction, and which inputs are unimportant. This graph shows the predictive value of the various input features. I invite you to pause the video if you wish to study this graph. Note that the length of the bar does not say anything about the ideal value of the variable. It only describes the variable's importance. Let me explain by taking a look at the top three variables. Looking at the box plot, we see that buyers, people who did purchase a package, had, broadly speaking, a bit less monthly income than non-buyers. Looking at the product pitched, the categories are arranged alphabetically, but notice how take-up declines as the luxury level increases. See how pitches for basic and standard result in a higher percentage of sales than, say, King or Super Deluxe. Looking at the passport variable, we see that passport holders are much more likely to buy than non-passport holders. From this, it looks like there may be a sweet spot for sales to passport holders wanting a relatively basic package whose income falls in the range of the blue box on the box plot. Now let's look at a couple of unimportant variables. Two unimportant variables were whether the customer owns a car and the number of children under 5 traveling with the customer. Note that take-up is about the same whether or not the person owns a car, and take-up is also about the same regardless of the number of children traveling. To review, I discussed briefly the background and objectives of the project. We looked at the available source data. We created a number of machine learning models and chose the most suitable model. And finally, we discovered what variables were more important and which were less important. This concludes my prepared remarks. If you'd like to get in touch with me to discuss how I can create a similar analysis for your business, please get in touch with me through my LinkedIn profile. So long.